Today we will not have very long one, so it will be somehow short lecture. And also you should expect I should have already published the grade for assignment 1 the last week, but I have some health issues. I have been isolated at home. This is why I was feeling sick. Now I'm better, so I think that I can do it this week. The next week there will be no lecture because it is a reading week. So for all of you, as far as you know, that there will be no lecture, no classes, no exams the next week. And also I will not send a lecture for the next week, so we will have this lecture 6 and lecture 7 will be after the next week. And you should expect that. Yeah, go ahead, Kura.
Just noted.
Yeah, thank you. And we also will have assignment 2, which will be published by this week also, after I publish the grade for assignment 1. And I will publish, I think so we have enough material now to publish the guideline for the project. So the project presentation, it is a must to do it. You will not do it if you don't do it live. I will send a guideline for this. You should make a presentation, recorded one, and send it to me. Also the code of your project. I will send a project guidelines project delivery guidelines for you all. So, but you should start preparing for the project, I think so. At the beginning of the year, I have already, I don't know, Kura, have I already break you down, or did I broke you down, or still 2 groups in this course? Do you remember?
I think we're already in a group.
Okay, perfect. So since you are in a group now and you should communicate with each other after I send the project guidelines, so I will just send you a guidelines. However, I will be flexible that you can propose your own subject within the guidelines that I will share it with you. Kura, how so far can you give me a feedback about the course so far, according to you?
Okay. In Java.
Yeah.
In OOP, so.
Yeah.
Actually, I just do some group activity. So I have two activities that I've done with myself. So last week I don't try the last week activity. So I think I have some confusions in some areas, but I think I can Google it.
Okay, it's very. As I always say, when we talk about programming, we need to have somehow weekly practice. I'm not talking about here group work in general. You all as a student, you should have your only weekly practice in order that you can enhance your programming capability. This is what we are now discussing in the Java OOP, in general OOP concept, and then now we are discussing different data structures for this OOP concept. The importance of this, it will help you more understand the logical way in order that when you have any program, even though, by the way you practice your mind, how you think to solve a programming problem, you will also use the same way of thinking with different programming languages. It's not only Java. Yeah, we are going to apply the way you solve a problem using Java syntax, but also this will enhance the way you think to solve some logical problem concerning programming tasks that you are going to face in this course. Okay, the last time we have already talked about Java enums, and then we talked about how we can get an input from the users, and we start with the array lists. The array list that we discussed the last time, it was the first dynamics data structure that we deal with before we normally we know the classical one, like the array one, and that has a static side and static number of elements that you can insert in this. The array list was the first data structure we have to deal with, which is we are going to deal with dynamic collection of data. However, it has some advantages, this array list, especially having this dynamic side, but still have some disadvantages based on the, we will not, today we'll discuss it when we will have more data structures to talk with. In this course, we focus more about what is a data structure, how you can use it. However, comparing the complexity of different data structure, it is out of the scope. It can be more in the algorithm and data structure course. But in this course, since now you are familiar with the OOP concepts, and you need different data structure and different programs that you are going to build. However, we are going to discuss the advantage, disadvantage, or comparison between different data structures, but we will not go to the complexity estimation, because again, it is more about algorithm and data structure course. However, we are going to discuss the advantage, disadvantage as a comparison between different data structures. Today, we will have a linked list, which is another data structure and HashMap. We will have a group work, but it will not like a programming group work. So me and Cora, since Cora only today here, we will discuss more about the difference between these two. We will let's keep it till the end of this lecture. So let's start first with the Java linked list. So far we know about array. Sorry. My mouse should working now. Yeah. So far we know about an array that it is a collection of different elements, and each element will have an index, and we normally start with index 0, 1, 2, 3, 4. The array and the array list is the same, that both of them, they will deal with the data as an indexed element. However, the main difference will be in this case that if there is an array list, we can put whatever a number of elements we need to put, not like an array, as I said at the beginning of this lecture, with a predefined list that we are going to define. Here in the node, on the linked list, sorry, we are going to deal with the element like a different node. Each node will have the element, the data, and it will have a reference to the next node. So each node will know who's before, who's after. This is, and each node, it is about let's say we will have two objects, we have to deal with them, the reference for the next node and the element in this case. So if you are going to insert, for example, a number 4 in the array, that suppose that we have an array like this, we have 1, 2, 3, 5, 6, 7, and you want to insert an array here in this array number 4. According internally how the array will work, again, then when I said array and array list, it will be the same here in this case. So how it will work, that I need to increase the size if it is an array list, for example, and I have flexibility with the size. And then I have to move all this number to have a space for 4, and then I will put 4 here. This is how internally will work the array in this case. And then I will have this 4 here. However, in the node, when I have a linked list, I just create the new node, which is the number and the reference. I will disconnect this, and then I will make a link to insert the 4 here. So I will not shift all this number in the memory. I will not do this. And this is a very important point that will make the linked list when you are going to manipulate the data, which means that you want to insert a new data or update the existing one. It will be faster comparing to the array one. Because the array, as I said, if you want to insert an element in a special position, you are going to shift all other elements to have this new space and then insert the element. In the linked list, since we are dealing with the data as a collection of nodes, and each node had an element and had a reference to the next element, and sometimes if it is a double one, and normally this is a single one, and then if it is a double one, we will have a reference for the one before and the one after in this case. So we have a reference for the neighborhood. So if we are going to add a new element, just we create the node one, and we will update the reference. So 5, for example, if the 2 has a reference for 5, I update the reference of 2 by adding the reference to 4. That's all. I will not shift the other in my memory. Because in my memory, they have an element, the data, and the reference. So I just update the reference. In this way, for data manipulation, for updating the data, the linked list is very faster. Both of them, they have a dynamic size. Both of them, you can insert, I'm talking about the array list, not the array. You can insert as much as element you want to insert in both of them. However, whenever you want to update the value or insert a new value, the linked list in this case will be faster comparing to the array list. Because here, for example, in this array list, so normally the array list will start with a size of 10, for example. And then if this is full, let's say in this case, the array list will take more time compared to the array in this here. If it is full, and then in this case, we have to increase the size of this array list, and then as if we are going to build a new array, and we have to move the old one to the new array, and then we are going to insert the item in this case. So it requires extensive, as I mentioned here, it requires extensive data movement, the same as a normal array when we talk about array list also. So what is different methods we have it that we can use them in the array list? Sorry, in the linked list. Add or add last. So first, there is a function I can call it in order to add a new item. So either I will add this new item at the end of the list, this linked list, or I can use also the add function without passing an index to the add function. Both in this case are the same. This example I have already here a linked list. I name it Li. It is a new linked list. And then I will add them. This is H, this is E, this is A, this is P. So this is a linked list after I using the add one, and also I can add the add last. It is the same as the add in this case. It will add this element at the end of the array of the linked list. So what about if I want to add to a special position in the linked list? So I can use this add function by passing two parameters in this case, the integer index and the object element, or the object that we want to add in this case. So here, I also, again, the linked list, you should be aware when you want to create a linked list that you have to import java.utl.linkedList, as we did in the array list. And as we did that with the array list, when we are going to create the linked list, we use linked list, a new linked list, a constructor like this. And normally we have to pass the type of the data that we are going to put in this. And you can omit this also, it also will work. And this, because a linked list will deal with the all element as an object. So either you will define the object what they are, or just you define the linked list and then you can insert the object and it will take the type of the object that you are going later to insert. So, but normally it is preferable that you start like this by assigning what is the type of the object, because when you pull it, it will pull it as a string. However, if you don't assign a type, you have to take it as an object, as a generic object one, and then if you are going to pull it and then you are going, for example, to print it out, you are going to change it to string object later if you didn't start with it as a string linked list. So preferable to declare the type of the object when you are going to create the linked list, as I do here. So here I have here HEAP, and then if I want to add an item, I said here 2. So it's according to the index here, I have 0 here. This is 1. This is 2. This is 3. So I want to add a new element at 2, as I did here. So I said add to S. So again, if you can see that as if you are dealing with the array list, but again, it is more faster because like here, what I want to add here, this is, if it is an array list, what will happen in the memory that this is all will be shifted. And then I will have a new space, then I will put the S. However, before I put the S, I have here, like here, H, E, A, and P. And then here the E had a reference to A. So this reference, which is a value, I just change the reference after I will create a new node, the S1. I will add the reference, this is to A, and I will update the reference of E. Rather than having a reference to A, it will have a reference to S in this case. So you can see it is very faster comparing to the array. I don't shift the whole element. We are taking in the lecture very simple examples. However, in reality, you are going to deal with a very big amount of data. So it will take a very huge processing time. If there is a huge amount of values in this array list and you want to insert a new value, so it is going to shift the whole values to have the new space that you need. Here, no. Create the node, update the reference of the node that will come before it to refer to it, and update the reference of the new node to refer to the next one. That's all. The other will not, nothing will be happen to other element like changing them in the memory to another place. They will stay as they are. Just we are updating the reference of each of the neighborhood neighborhood nodes also. So if there is another function, name it addFirst. So addFirst, I can use it to add at the beginning of the node list, as we do here. remove first. So I will remove an element from the beginning of this linked list. So I have this linked list, I created it and add all this function. And then if I want to remove h, what I will do, I will use this function remove first. In this case, I will remove h in order later that I will get EAP, which means that there is no any more h in this list. What about if I want to add first? This is, maybe we have already discussed this at first. Remove last. So the same as we did in the remove first, we can make the remove last. Like here, I have here, this is an array linked list. I'm always get accustomed to the array list. I don't know. I want to say always array list. So I have this linked list HEAP, and then what we will do that we will move the last one, P. Just call a function remove last. All this function, they are defined here, so I'm just using them since they are defined here. And then I print out again this array, this linked list after removing P. So I have HEA. So now what about if I want to remove a special value or a special node in this linked list? So like here, I want to remove A. So there is also a function remove index, integer index, which means that in this case, I have to pass the index like here. This is again, the index will start from 0, 0, 1, 2, 3. So if I want to remove A, it had an index 2. So I will call a function, I name it remove 2. So you can see that the content of the linked list here will be this. HEP, which means the A doesn't anymore exist here. I will now, let's make this comparison based on this definition, the old definition that we have it for the array list. And this is the new definition or the new data structure that we have already discussed today, the linked list. So the first one, this class use a dynamic array to store the element. So it has a dynamic array. The linked list use a doubly linked list, which is to store element, which means that this is use an array, set of location in the memory, and this is will use a linked. Why we said a linked? Because we have a reference to the next each one, and there is a reference to the one before. So they have a link, which is a reference, which is the value of the memory location of the node. Here, this is very important. Very important difference between both of them, and we have to consider this is when you are going to implement your own software or you are using which data type or data structure, you are going to use. So manipulating array list take more time. Manipulating, what you mean by manipulating, which means adding new value, updating the existing one. Whenever an element is added, all elements after that position are shifted, as I said. So this is element 0, 1, 2, 3. So if I want to add a new element here, suppose we have more 4, more 5. If I want to add a new element here, all these elements should be shifted in this case in order to insert this element here. However, in the linked list, it will take less time because whenever an element is added, all element after the positions are. So sorry, this is the same. There was a mistake here. It shouldn't be here. I will update this in the last version. No, whenever an element list time, because as I said, we are going to update the reference in this case. So here it should be updated here in the lecture note. I will update this later. So in the linked list, if I have this as a linked list, I want to add a new element. So no shifting. Here it will refer to this, and this refer to this. What I will do, I will let this refer here, and this will refer here. That's all. Updating the reference. Array list consume less memory than linked list. Consume memory, yes. I'm talking not about manipulating or adding new items. As I said, the operation of adding new item in the linked list will take less time compared to the array list. However, the array list will take less space in the memory comparing to the linked list. Why? Because for the array list, I need just space to put the element, and I put them in a consecutive way, so to have this the index for them. However, here I need a space to put the element for each node and also the value of the reference. And if it is two-way linked list, so in each one I have a reference for the one before and one after. If it is one-way single one, I also need a reference. So the reference, what is a reference? As I said, the reference is the location of the next node, for example. So this value, I'm saving it. It takes part from my memory, from my RAM memory, because when I'm using a software, this data structure, this take part from my RAM. So in this case, I need more space for the linked list comparing to the array list. So when to use this and when to use this? This is a very big question. Most of us will say, okay, both of them, they are data structure. Both of them, I can use them to save list or a collection of elements. So one to use this, one to use this. So this class work better when an application demands storing the data and accessing it. This when the application demands manipulating of the stored data, which means that if you see that you are going to save this data and and there is no much operation in updating later the value till you end your application, there is no much. For example, you are reading the data from a sensor, and these data of this sensor, you are save them in array list because you need to process them later. However, if you are going to deal with a data, and this data you are going later during running your application to change them, not only to use them, again, to change them, not only to use them, then you are going to go to the linked list, not to stay at the array list in this case. So now depend. If you are going to store data and use them, not to change them later, go to the array list. If you are going to store data, but you expect to manipulate them, go to the linked list in this case. Because now you will take, when you go to the linked list, you will need more space. However, it will have more efficient way in order to update the existing data in the list in this case. Cora, do you have any questions so far before we go to the HashMap?
I just want to clarify for the data type used in linked list. So
Yeah.
we can put string and integer, or only string type?
No, you can. If it is a string, then it is only string type. But you can also create one with integer one.
Okay.
With double one.
Okay, but, like in array list.
Yeah, it's like array list. But what I said that if you didn't mention here the type here, the compiler will not give you an error. It will work. However, it deals with the data as an object. And later, when you pull the data, for example, you want to print out the data, you should be aware that you are going to make a casting for this. So don't do it like this. Don't go ahead and create as an object, and you know that this object has a special type based on the way that they're going to use this. You get it in what I mean by this?
Yeah. So if I will use like it, I will not use it as a string. So I will put it is as an integer.
Yeah, if it is not string, then if you want to use it as integer, then you can go it as integer. Yeah, yes, double, float, whatever it is.
Yeah.
But yeah, so declare that type before you will use it in order not to make a casting when you pull the data, because when I pull the data, I just go ahead and print it out because according to what I hear, it is a string one.
Yeah. Okay, thank you.
Yeah, sure. The last part is HashMap. So array list and linked list store the data in an ordered collection. So in the array list, we will have index 0, 1, 2, like this. And in the linked list, we will have also an order. This is 0 node, this is node 1, this is node 2. So we have always an index for each element. And in the linked list, there is also the reference for the next node. Now the big question, now we have another data structure we can use it, which is the hash map. The hash map, you are going to save the data key value. And this key can be string or can be integer. Sorry. Cora, if you remember in the web programming, it's like associative array.
Okay.
So we said when we talk about associative array in PHP, we said there is a hash map that we can consider it also here in the Java. People who are familiar with it. So the data will be key value, key 1, value 2, key 2, value 2, maybe value 1, value 2. And this key can be string. It doesn't mean that it should be integer. Like in array, as we said, that each one will have an integer index. Also in the node list, which is the linked list, we will have an integer index for each node. However, in the hash map, we will have a key value. For example, you said you put a key like name value Ismail. You can put another key like age, and you can put a value. So you have a key value, don't have any more index for each element. All this value for each value can has a key. And this key can be something rather than integer. Example, it can be string. And also can be integer, by the way. How we can create this? So I can create a hash map. Again, I have to import, there's java utl.hashmap. I have to import this in order to create the hash map. And then here I will make a new hash map. But here I have to declare the types of the key and the value. Because maybe the key can be integer and the value can be string, or the key can be string and the value can be integer. So I have to give the both type of the expected key and the value that I'm going to use for this one. Here, this is now, let's talk about basic operations. As I always say that we discuss in the lecture the basic operation, but there are more operations. We just discussed the basic one, the most important one, the most widely used one, but this is not always the one that we have to discuss it. No, this is this is what we have to discuss it, but there are more in the literature about more operation that you can use them. So here, this is, if I want to add an item, I can use a put method, like here. I created this hash map. So, and then I said, okay, capital cities, and then I have to pass two values. Here, this is the key, and this is the value. This is the key, and this is the value. So this is the city, and this is a capital city. This is a city, and this is a capital city. So I can use a put method to add these two values by passing the key and the value, as I said. And at the end, I can print this out by saying system.out println, like I said it before, and passing it. I will catch this. So how I can access it? I can use the get one. But here, I will pass the key of the value that I want to retrieve. The key of the it doesn't mean that the key can be, as I said, integer indices. In array or array list, I will say, okay, get this for index 0, 1, 2. In the node also, I can go ahead and pick the element in node that has this index. However, here I will pass the key for this element that I'm interested to pull it out from the map, hash map that I have it. In this case, I will say, okay, get England, and then I said, okay, London. What about removing an item? So there is already a function named remove. Again, like when you want to get, you are going to pass the key. And also, if you want to remove a special item, you are going to pass the key, which is here in England. So in this case, if I print out here the hash map, the hash map has 3 different values here. And this 3 different values, 1, 2, 3, without the first one that we have already removed it from the list by passing the key. No need to pass the value, just pass the key and it will be removed in this case. If I want to clear the hash map, to remove all items in the hash map, in this case, I can use the other function named clear. So now if I print out, nothing is being in this hash map. So if I want to get the size of the hash map, there is already a function named size. I can use it and it will return the size of the elements in this hash map. Again, the hash map, it will be in my memory like this. The key and the value, England, London, Germany, Berlin. The most important usage for this hash map is that whenever I want to use an indices, non-integer indices for the values. So now what about if I want to make a looping? The next time we are going to talk more about iterator that we can use it in all collection, but not now. If I want to use the for loop, so I can make a looping based on and getting here, like here, this is, I use here the word key set. So key set mean that for, you see, I can use for each string I that the last time one said when this is a for each. We said for each, it's not like the classical for loop. It will take 2 parameters. The first one, the variable that we will use it to point to the values of the object that we want to iterate in, like here in this. Here we set capital cities dot key set. So we are iterating for the key set to the keys. So for I, which means that iterate within the key in this case. So print I, we will get all the key, sorry. Oops. He will get all the key, like here, US, Norway, England, Germany. If I want to get to iterate and get the whole values, so I can use values dot values here rather than using key set. This is, I said it will not be along today. I want to go to have this reading week and revise whatever all the material that we did it before. And I will send this time a long assignment too that will cover what we have discussed before. Do you have any question for me, Cora, so far?
None for now.
Okay, so my group, my question for you today, I will give you time to think about it.
Okay.
It is not something programming that I want you to do it. However, I want you to give me, based on this HashMap discussion that we discussed so far. So we discussed array list before and linked list, and I make a comparison between array list and linked list. I want you to make a comparison between array list, linked list, and HashMap, 3 with each other. What is the main difference between these 3, 1, and the one you think that we have to use this or this or this? So I need to have a table like this table, array list and linked list. However, I want to do it for array list, linked list, and HashMap.
What are the purpose, or what will be sample project that can be used by array list in?
No, yeah, no, as we did here, for example, I said array list. I make a comparison array list and linked list. There are some similarity and there is difference. So I want to make a comparison between these 3 now.
Okay.
Array list, linked list, and HashMap.
Okay.
We will stop recording in order that I will help you. Don't worry about it.
Okay. So do I need to write it length depends on what you will be put on the array list, and the data type should be same, like string. It should be put string on the array list, like
Okay.
in linked list. Array list, we save more memory than using the linked list. Then
yes, one about the space.
the space
because
of
we store just an element.
Yeah.
But we need more memory if you want to change the array list.
Like adding an element.
Yeah.
Yep. So, and it is sequential order, like it use index. So 0 to start with 0, like linked list. So in linked list, it is node. We imagine that as a node. It pair with what do you call this? The what do you call the index and the call a friend? What do you call that?
Which one you mean?
When it is a node, linked list. It's like
the next list, you mean a reference?
Yeah, it is
reference
it's
to the next node.
Yep. Then it consumes more memory than array list, and it is good in manipulation, data manipulation, because
it's faster, because if you want to add a new data, a new node, it will be faster comparing to the array list.
Yep.
What about the HashMap?
HashMap, it is a key value, so it is key, then it pair with the value. Example name, then the value of the name. So it is like that. It is pair with, it is like associative array.
Okay.
Yeah.
By the way, it's perfect. You did it in a good systematic way. I like it. It seems that you understand the concepts of the array list, linked list, hash map in a correct way. This is my concern, because we are going to practice more exercises later in the assignment and others, and also during the lectures for the upcoming one. But yeah, let me share mine also. So if I will go to So as Cora said, so I will go to that array list. It store element value and maintain the index of each element. So I will have an index. However, we just store the element value. The linked list will store the element value and references for the neighbor node. And also it maintains the index for each element. The hash map store element key value. It has to store the key and value. The second, it has to store the value and the reference. The first, just the value. This is why the array list would take the less space needed comparing to the others. So the array list will maintain the order since we use the index, and also the same linked list. However, the hash map doesn't maintain the order, which means that you put an element now, then you insert another element. No. Whenever you can put the data, it doesn't mean that should be an order way. However, each data had a key associated to it to pull this value later. The array list will allow duplicate element. Also the linked list in this case. However, in the hash map, you allow duplicate value, but we don't allow duplicate key, because the key, it should be unique. You can't have two keys in this hash map. In the array list or in the link, even though you will have the same value later, but each value will have different index, so it's okay to have duplication here. The key, that we are going to insert, it should be unique, no duplication in this case. The index, we don't insert the index. The index is the order how the data is being saved in this array. So duplication is allowed in the array list, linked list. However, the hash map is allowed in the value, but not in the key. Here the usage. Let's summarize the usage. So array list makes sense when it's important to maintain the same order. So the order is an important parameter to us. And also you need a quick access time based on the index, which means that position and index. So just you can set array of indexes and you pull the value in a very quick way, because the linked list, it will be more if you need an order, if you need a data structure to be quick in the insertion. We are not talking about the pulling of the data, we're talking about when you are going to insert or manipulate, as Cora said, the data. The hash map, it makes sense to use it when the unique keys are available for the data we want to store. So if you are dealing with a data, there is a special keys for this data that you want to store it. Now you can go to use a hash map. But if you don't have a key for these values and you are going to give them indices, so go ahead to the array list and the linked list in this case. This is what I want to share for today's lecture. As I said, it was not a long one. However, we will focus more practice exercises in the assignment. I will share also the solution for the assignment 1 with you after I publish the grade. Any question for me, Cora, today?
None, sir.
I'm happy that you are here. And I said I encourage all. I shifted to 5 p.m. that more people can join if they can. Now it has midterms. So again, I will encourage you to do it for the not the next week, the week after. And always I am available by email and also by virtual office hour. If anyone need any support, go ahead and book with me one-to-one meeting. Cora, pass my hello to your daughter and to your kids, and
Okay,
have
sir.
all nice evening.
Thank you, sir.
Yeah, take care. Bye-bye.
Sir, can I ask you, but not related
Yeah, sure.
to OOP,
Sorry?
but not related to OOP, to PHP?
Let's stop the recording here and you
Okay,
can ask me.
sure. Thank you.
I will